Hello and welcome to 10R procedures to commit to memory. I'm Dr. Mark Williamson. Let's get started. So the procedures we'll talk about today is loading in data, dataset creation, summaries, tables, mutation, grouping, linear model creation, and plotting histograms, scatterplots, and bar plots using ggplot. Because if you work in R and you code in R, there's some things you do a lot, and you want to be able to not just have to look them up or Google them every single time. Some of these really foundational procedures, it will pay a lot of dividends to sort of memorize them, commit them to memory so you can always pull them up and do them right off the bat. And so that's what we'll take a look at today. So just a little bit of color coding about the outlines, and then we'll jump at the end to actual R coding. But when I have here on these slides, if I have red, that is data dependent. So it'll depend on how you name things or load things in, or what sort of variables you're working with. And then if it's blue, that's sort of data independent. That's the structure of like how to write the functions or format the code to do what you want here. And so that's just a little setup there. All right, starting out, loading in data. That's going to be a big thing you want to do. And the most common way I do this, or the most common method, is loading in a CSV file. So I need to remember to use the read.csv function. That's going to be that. And you can use an arrow to save it to an object. So you can name it whatever data set, and you're going to need to read this in after making sure your path file gets to wherever your CSV file is on your computer. But that's going to be parentheses, and that's going to be what the name is, and then the .csv. So that's pretty straightforward to remember. I think I can typically always remember that. Now, on the other side of things, we have number 2, dataset creation. Sometimes you create a dataset rather than just simply loading it in. And that's a little bit more involved, but again, think easy enough to remember if you take some effort. So again, you're going to call it whatever you want, and you're going to call data.frame. And then you're going to need to set up. So here I have the Y and the X. Those are going to be whatever the names of your columns. So I'm just going to call this Y and this X, and then you're going to make a concatenation, so C function, and then whatever your actual variables in the column. So those are going to be the rows. And so here, this is a very small one, just 1, 2, 3, and then if it's sort of a category, if it's strings like A, B, and C. And so that's the general format. So easy enough to remember, and then you can extend it out to whatever your data set needs to look like. All right, summary. A lot of times you need to summarize both data sets or maybe a model you ran. So you simply just need to use the summary and then put the data set in there if it's a data set, or if you say like the results of running a model, like a linear model, like say, for example, LM1, that's just the name I would give. You can summarize that and it'll spit out the results, the p-values, the model parameters, etc. All right, moving on to tables. It's usually good for getting counts across categories. So the simplest table is a one-way table. You're going to have your data set, you're going to have the $sign, and then whatever your variable name. So categorical variable name, and it'll give you the counts per each category. Now, if you want to do a two-way table, you do the same thing here, only you have a parentheses between the first categorical variable and the second categorical variable. And so you can do 3 or more, but that starts to get complicated. But that's really how to do a very simple table. All right, next, mutation. And I'm thinking actually mutation is in the dplyr, so you're going to need to make sure that's loaded in, the tidyverse type things. But not just mutation, because there's a lot of different ways you can use the mutate function, but I'm specifically thinking of one that I use a lot that's sometimes hard to remember, so I'm trying to commit to memory, is I mutate with the case when function inside of it to help make a new variable based on metrics from an existing variable in the data set. So this is what it would look like. So first of all, you can sort of use the piping operator to sort of save this data set into the data set you already have, so it adds to it. I mean, if you want to make a new data set, you can, but typically I just because I'm adding a variable with a column, I'll just keep the same. So you use the mutate function, and then you're gonna whatever your new variable, so variable 2, it's gonna equal, and then this is the case when function. So you're gonna do case underscore when, and then in parentheses, and then so this is the setup here, which can be a little complicated, but once you use it, it's really powerful. You have variable 1, which is one of the variables all in your data set, and you do double equal. So whenever the variable 1 equals 1, you have this tilde, and then you tell what value to give variable 2. So when variable 1 is 1, I want variable 2 to be A. Say I'm separate out into like categories, like A and B here. And if variable 1 is 2, I want it to also be A. But then when variable 3 is 3, I want it to be B. And then this really important, and I forget this a lot, so I really want to commit this part to memory. You can actually have this function here, or this option here, where you say true in all capital tilde, and then have an outcome here. And this means that like for everything that isn't sort of specifically set up here, for all other values, it's going to be B. So say variable 1 was like 1, 2, 3, 4, 5 or something. Well, we have for 1, 2, and 3, but then for 4 and 5, it isn't specifically lined out. So anything else, so 4 or 5, it's going to default to B. And we'll see how this looks in an example. But that's really powerful to be able to mutate your data sets to create additional columns, especially if you need to subset or organize them differently. All right. Speaking of mutate, we have grouping. There's a lot of different ways to group. And this is often really important to sort of summarize data, both for looking at, but also for maybe creating good graphs. So in this point, I typically create a new data set. So data set sum, so you have the arrow, and then you pipe using the piping operator. Then you're going to use this function group by. And so you're going to group by some sort of categorical variable. You use the piping operator again. And you just use the function summarize. And this is, you can do a bunch of things, but this is typically the setup I use the most, because this is typically the information you can get to make something like a bar plot. And we'll see how that works later on with a bar plot. So you're going to create a variable called mean in this new data sum data set. And it's going to be the mean of whatever numerical variable in your data set you want. So numerical variable 1. And you can also do standard deviation, again, using the function standard deviation of that numerical variable. And then these are really important. This error, UL, and LL actually takes, the error is this function that involves, especially the standard deviation. And then the upper and lower uses error later, and then the mean. And then so you can get error bars for the bar plot. And that's why I kept this here. It's a little complicated. Obviously, you could, if you just needed median SD or even median or max, you could have this set up differently. But the most common way I use grouping is to get error bars for box plots. So that's why I'm trying to commit this type to memory. All right, 7 linear models. So for the simplest one, if you can use the function LM, linear model that's built in. You need to have a y variable, tilde, so this is going to be the function y variable is a function of your x variables. Here I have 2, you could have more, you could have less, you could use interaction terms, etc. Then you need your data set. Save that as an object. If you want to do like something like a generalized linear mixed model, you need to use LME4 package, and you can use the function glimmer. Same sort of formula in this first part, but then you can add your random effects with parentheses 1 / bar, and then whatever your grouping variable is. And then it's going to have the same data set. And then you're going to, because this is generalized models, it doesn't necessarily have to be Gaussian or normally distributed. You can set the family functions. So for example, I could do Poisson here. And so both of these are useful to try to memorize. All right, finishing out here with some graphs. We have the histogram, and these are all in ggplot. So again, you'll have to have ggplot2 loaded as the package. Histograms, you can save it as a object, so a plot, and then call it later. But you're going to use the function ggplot. You're going to need a data statement, and then this AES aesthetics. And for a histogram, you just need to have an X variable. And so whatever numerical value you want to have a histogram. Now, of course, you could do a more complex one. You could have a group and look at like, male, female, model A, B, C, whatever. But for the simplest one, you just need to have an X value. And you add a plus sign, and then you add your geom underscore histogram. And you can leave this empty. You can see there's options to upgrade this, but this is the simplest histogram. Similarly, for a scatter plot, you can do the same sort of thing, but for ggplot dataset, but in the aesthetics, you're going to need to have an X and a Y variable, and these are going to be numerical. You're just going to apply in the X points in the X and the Y. Of course, you can add grouping to have multiple ones, but this is, again, the simplest. And then you need to have the geom point. And you could stop there, but I think what's really important, especially for exploratory data analysis, or exploratory data visualization, is to have a measure of the fit. And so you can use this geom underscore smooth, and then the method can be LM, linear model, and that should be in parentheses, so you can actually get a line of best fit. And so that would be a scatter plot. And finally, the most complex of the simplest plots is typically actually bar plot, because you usually need to use summarized data. So unlike the other ones, which you use maybe the raw data set, you probably all need to do that summarized step that we showed earlier. So have your data as your whatever summarized data, your aesthetics, the X can be a group, so a categorical variable. Your Y can be the mean. And then if you want to color this, you can fill by group, and I typically want to. You can add this, and then you can do geom bar, and then you actually need to put stat equals identity, otherwise this doesn't quite work out of the box here. And then if you want those error bars, like I calculated for my typical summarize, you're going to need to add geom underscore error bar, and then with the aesthetics, you can do the Y minimum and the Y maximum to be those variables that we calculate for this data set, some lower limit and upper limit, ULL and UL. And that will get you a bar plot. All right, so that was going through really quick, things to memorize, but let's actually see what those look like in action. So I'll turn to RStudio for some toy data set work. Here we are in RStudio. So you need to make sure to load in your packages for this. So we need dplyr, ggplot2, and lme4, and then set your working directory to wherever your data sets you want to load in. So first example here is loading in data. I have this toy data set called Dino Survival. I had a CSV file, so I can use that as my example for the loading in data. So I just need to call it something. I'm going to call it Dino set, read CSV, and then that in parentheses. And once I load that in, I actually can take a look at it using the head function. And if we see down here, we see there's 4 variables: type, ID, time, and status. Now for the second one, if we wanted to create our own data set, again, going with the Dino analogy or Dino theme here, I'm going to create something called Dino set 2. I'm going to use data.frame. And again, each of these are going to be the different column names. So I'm going to have a name, size, type, legs, group, and length. And each of those are going to be a concatenation. So I have 6 dinosaurs from Ankylosaur to Tyrannosaurus. Different sizes. This is just made up data here, just to prove a point here of running these things. Sizes, bigger and smaller. Types, H being a herbivore, C being carnivore, legs being 4 only. They can only walk on 4 legs, 2 to 4, like, the iguanodon and hadrosaurs could be like 2 or 4-legged, walk on 2 to 4 legs. And then the Allosaurus and Tyrannosaur are just 2 only. They're only bipedal. Then just from random group for later, and then length, again, making things up. And if I run those, I can take a look at the head. And yes, I successfully created a data set, or a data frame, if you want to call it that, using the data.frame function. All right, if I want to summarize, I can summarize the data set, and it'll do that for character variables. It'll just tell you that. For numerical ones like ID, time, status will give you like mean, median, min, max, quartiles. And if I want to summarize a model, so I'm going to actually run a linear model inside of here with dataset 2 as size as a function of type. And again, this is just a little toy dataset, so this is not fitting any of the linear model assumptions. The data is way too small, etc. But it'll actually, still produce this. So actually don't take the results seriously, but you can take seriously the fact that you can summarize data like this. All right, moving on to tables. Again, this is going to be for categorical counts and categorical variables. I'll use my dataset 2 by type. You can see here. Let's see if we can share how well that shows up here. There we go. So we have 2 carnivores, 4 herbivores. If I could do this a two-way table like I showed before, we can show, this is again the categories of carnivore and herbivore, and then like whether they're 2 to 4 legs. So there's 2 of those ornithopods. 2 only, those are just the carnivores, and then 4 only, like ankylosaur and triceratops. Those are herbivores. So that's a quick example there. All right, mutation. So say if I want to, these are colored and I want to color them or tell that they have colors, I'm going to create a new data set, not a new data set, a new variable within my dataset 2 called color. And it's going to be based on the name of the dinosaur, case when. So I know ankylosaur is red, so I'm going to, if the name is ankylosaur, it'll be red. If it's iguanodon, it's going to be blue. If it's allosaurus, it'll be red. And then everything else, it's going to be gray. We can see that's really powerful. You can see, shows it here, the ones I specifically laid out. Ankylosaur is red. Iguanodon is indeed blue. Allosaurus is indeed red, but then everything else like Tyrannosaurus, I didn't name it, it's going to be gray because that's under that true everything else. All right, moving on to grouping. So I'm going to create a new data set now called dataset to summarizing. So I'm going to group by type of data, carnivore or herbivore, C or H, and I'm going to create the mean standard deviation of size, and then get those error bars, or values for error bars. And we can see here, pretty straightforward. And again, this is a very small data set, so the lower limit is crazy and like not biologically plausible for the carnivores because there's only 2 of them. It's like huge and then like negative. So of course this is not, and this is made up data anyways, but I'm just showing you how this would work for your real data sets. But it still works with this toy model. All right, moving on to linear model. Again, I can use LM, size as a function of type. We've seen this before, though I'm actually saving it as an object now. I can summarize it. Same sort of thing here. We get information about coefficients, estimates, p-values, t-values, f statistics, whatever you need, and then GLM. So this is glimmer, should be glimmer. And if I run this, there we go. And again, don't trust this at all because this is too small of a data set to fit the assumptions, but we can do that. All right, closing out here with histogram, we're going to look at dataset 2. We're going to look at size. And of course, there's not a lot of data here, but they'll still create a histogram. If you have more data, it's going to make a much nicer histogram. If you want to do a scatter plot, I'll do size by length. And I have the geome smooth with the linear model, so we can see sort of as size increase, length kind of increases as well. It's, of course, made up data. It's kind of all over the place. And then finally, bar plot. This is where, again, the grouping, the summarizing, the grouping, memorization really comes into play here. I have my dataset to sum. I can do by type, herbivore or carnivore. I can do mean and fill by type. And if I run that, it should let me see this. And yeah, you see carnivore, just error bars are all crazy, but they're there. And then the herbivore is a little bit more respectable because there's more of them. And there we go. Well, with that, we've covered loading in data, dataset creation, summary, tables, mutation, grouping, linear model, histograms, scatterplots, and bar plots, all in R, and even a toy example. Hopefully that has motivated you to think about the most common or useful procedures you use in R and commit to committing them to memory. Thanks for joining me. I'm Mark Williamson. See you next time.